Yeah, yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Oh, your screen is visible for me.
Yeah, fine, thank you. So what is big data? Why Hadoop and Spark? Drawbacks with the current databases. Drawback with the current databases. Advantages. Hadoop and Spark. Scope and job market. Hadoop and PySpark. Yes. So what is big data? Why is Hadoop? Why Hadoop and PySpark? Drawbacks with the current databases. Advantages of Hadoop and PySpark. Yes. Scope and job market of Hadoop and PySpark. Yes. So myself, I am Vijay. Like I hold 20 plus years of experience, which includes in different technologies, right? Yes. So this is what I'll be discussing, right? So here in this course, you'll be learning about four things here: big data, that is Hadoop, PySpark, Linux, Python. Yeah. Starting with the big data. Starting with big data. One second. Big data, the name itself saying like huge volumes of data. Currently, how the data is getting stored. The data storage units, right? You should have seen KBs of data. You should have seen MBs of data or GBs or terabytes of data. But today, data is getting generated in petabytes. Data is generated in petabytes, right? 1 petabyte equal to 1024. 1 petabyte equal to 1024 TBS. Means, yeah, 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit, but petabyte equal to 1024 TBs. So examples of petabytes of data generation. Pet examples of petabytes of data generations, right? We take example of any banking sector like SBI, any banking sector like SBI or HDFC. Within the city, you see hundreds of branches of SBI. Within the entire state, you see thousands of branches. Within the entire country, lakhs of branches for SBI. Again, within each branch, millions and trillions of customers, right? Again, they are making multiple transactions per hour, per day, per week, per month, year, right? So huge data is getting generated. Forget about this banking sector, but you are aware about social media like Facebook. Facebook has got users not only within the country, entire world. It has got millions and trillions of users throughout the world. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated in a minute? Huge data, right? So Facebook generating data in petabytes. Not only Facebook, today if we talk about different applications, then generating data in petabytes. Facebook, if I take 1 minute transaction, 1 minute transaction, if I take 1 minute transaction, what is the data generated by Facebook? What is the data generated by Twitter tweets? What is the data generated by Google queries? Today, everyone are querying in the Google, right? What is the data generated? Data generated by Google. And YouTube videos upload. What should be the storage capacity to store all the videos, right? Email or Gmail messages. Storing millions and trillions of users. There's now has talking about bank transactions, telecom transactions, bank transactions, telecom transactions. We talk about the Flipkart and Amazon transactions, e-commerce transactions. Everywhere we see like huge data is getting generated in petabytes. Currently, we have got databases. Currently, we have got databases, right? Databases like Oracle, MySQL, DB2, SQL Server. Currently, we have got databases like Oracle, MySQL, DB2, SQL Server, right? Yes, for OLTP operations. Yes, currently we have got databases. Currently, we have got, okay, for OLTP operate, and we have got some specialized databases. We have got some specialized databases. We have got some specialized databases which are used for data warehouse operations, right? Like Teradata, Netija, Vertica. Yes, specialized databases like Teradata, Netija, Vertica. All these they are used for OLAP operations. They are used for online analytical processing. Either these databases or specialized databases, they can handle data up to some extent, but beyond that, it cannot handle, right? Means if it is data in petabytes. So, as a solution to this storage level problems and processing level problems, right? We have got a framework. We have got a framework like Hadoop for unlimited data storage and processing. I'll come back to this, right? I'll come back to this, but today, if you see, this is your data. This is your data available in the current real world. This is the data. This is available in the current real world. So this from the year 1975 to 2025. If you take the last 10 years, 2015 to 2025, and the previous 40 years, the previous 40 years, the last 10 years, 2015 to 2025, the last 10 years, the previous 40 years, if you compare the data, right, the data generation, nearly 80% of the data what we are seeing in the current real world has been generated from the last 10 to 15 years. The previous 40 years, only 20% of the data has been generated. And that too, if you see, like GBs, TBs, or petabytes of data has been generated from the last 10 to 15 years. Previously, if you see, if you go back like 1990s or the earlier 2000s, you got to, how you used to carry the data. You got floppy disks like 1.44 MB. Later, you got compact disks in GB in MBs. Later, like DVDs. Later, you got USBs. Right. So day by day, the storage systems were increasing enormously. Now data has not reached terabytes, petabytes. It has reached. Petabytes of data is getting generated. So for a huge data storage and processing, we need to have some proper storage systems. Reasons for this huge data generation. Reasons for this huge data generation, especially from the last 10 to 15 years, because of usage of technology. Usage of technology, right? Because of usage of smartphones, because of usage of internet. Today, go back in 1990s, nobody knows about that internet. Now, everyone carrying internet, right? Smartphones, because of usage of technology, data has increased a lot. Previously, if we talk in the earlier stages, when the mobile phones were introduced in the early 2000s, to go back like 2001 or 2, see the internal storage was 128 MB or 256 MB. Now even 128 GB is a very small storage. In the coming years, it is going to reach terabytes and petabytes. So what are the main sources from where this data is getting generated? Mainly three sources of data. Mainly three sources of data. We say like social data. We say like social data, machine data, and transactional data. Social data, machine data, and transactional data. See, social data which has been generated from social websites, from Twitter, Facebook, all these things, right? Machine data means data which has been generated by reading, by scanning the RFID chips, barcodes, right? Go to a shopping mall for the items you purchase, a huge data is getting generated. Transactional data, day-to-day transactions. And if you talk about this, mainly three categories, three types of data. Three types of data. It's categorized into three types. Structured data. Structured data. Data which is organized in the form of rows and columns, like database tables, Excel files. Now, semi-structured data. Semi-structured data which is not fully structured, which is not fully unstructured, like XML files, JSON files, and unstructured data, unstructured data, right? Like chart messages, articles, images, videos, all this comes as unstructured. But today the biggest challenge is how to handle this, how to handle and process, how to handle this unstructured data. Talk about the databases. Databases can handle what the databases can handle only structured data. They cannot handle unstructured or semi-structured data. But Hadoop can handle all varieties of data, structured, unstructured, and semi-structured. So as day by day, as data is increasing enormously, we need to have proper storage systems for storing and processing the data. We have got a framework like Hadoop for it. Hadoop performs both storage and processing. Hadoop is able to perform both storage and processing. For storage, okay. So if we talk about any technology, right, it is either meant for storing or processing. If we talk about C, C++, Java, .NET, all this, they are meant for processing. Talk about Oracle, MySQL, DB2, SQL Server, all this they are meant for storage. All this they are meant for storage. Either they are meant for storing or meant for processing. So, but Hadoop performs both storage and processing. Does Hadoop use any databases for storing its data? Means no. I said there are some drawbacks with the databases. Despite of the drawbacks, Hadoop doesn't go with any database for storing its data. Rather, it's going with a kind of file system called Hadoop distributed file system. There is a file system called Hadoop distributed file system. It doesn't use any database. And for processing, does Hadoop use any technology like Java or any other, right? No. It's going with an execution model like MapReduce, but currently it is going with Spark. So Hadoop is meant for storing and for processing. So if you take big data, huge data generation, if you take big data as a problem, you can say Hadoop is the solution. If you take big data as a concept, they can say Hadoop as the implementation. Yes. You may ask what are the drawbacks with the databases? Databases are widely used, and drawbacks with the databases as compared with Hadoop. Why databases can't be used for storing Hadoop's data?
Because Hadoop stores huge data.
Yes, unlimited data storage. So drawbacks with the one by one drawbacks with the current databases. Current databases, right? Drawbacks with the current databases. First thing is limited storage. Limited storage, not unlimited storage, limited storage. Second is most of the databases, no parallel processing. No parallel processing is the most of the databases. And yes, any other drawbacks with the current databases means yes, if volume of the data is increasing, if volume increases, or if the data increases, speed decreases, I'm saying. In databases, if the volume of the data is increasing, speed decreasing. For example, try to check with this query, right? Select, I want total amount generated. So total amount from sales one, it has got 10 records. Total amount from sales one, which has got 10 records, sales two, which has got 10 lakh records. Total amount, select the total amount, total amount from sales 3, which has got a 10 crore records, 10 crore records. So here, if you observe, try to answer which query executes faster among these three. Which query executes
First one.
the first one, right? Because total amount of 10 records, total amount from 10 records as compared with 10 lakh or 10 crore records. The first query executes faster because of its less data, right? So query to query of data is increasing, speed is decreasing, right? Yes. And one more, if volume is increasing, if you take a labor example, a person or a boy, if it is carrying just 1 kg, he can that, right? He can run that. If that volume increases to 10 kgs, he cannot run, but he can walk with that. But if it is increased to 70 kgs, he cannot even walk. Means what is that? If that volume is increasing there, the speed is increasing there for the person, right? The same way here, if volume increasing, and if we take even if complexity increases, right, speed decreases. Yes, for example, even if we take an example, right answer for this, 3 to 4.
12,
12, that's fine. 12 into 6,
72,
that's fine. 23 into 32, try to say.
and take time.
524 into 732, 1083 into 9376. So here, complexity increasing, your speed is decreasing, right? If complexity increased, speed is in the same way. Here also, if I take labor example, if I take an example that is database point of view, if I take an example, I'll take the same query, total amount from sales one, right? Yes. Assume it has got 10 lakh records. Same table, but I'll go with different operation. Average amount from sales one. Again, same 10 lakh records. One more. Selector. This time, standard deviation of amount. Yes, from sales one. Which query executes faster here? Which query? Sum of amount or average amount or standard deviation? Among these three queries, which query executes faster? First query, right? Obviously, the first query, because average amount a two-step process. First sum has to be calculated, next average to be calculated. As compared with that first query, second query taking more time or not? This third query, standard deviation of amount, lot of internal processing is required, right? And if the major drawback with the databases, you see the fifth one, right? Databases can handle, or RDBMS can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. You see an example for this. You want to take reviews for a particular movie. If data is in a structured format in the form of rows and columns, for example, user is one column, review is one other column, right? User and the review, just observe. So in this way, user 1, user 2, user 3, in this way 100 users. They are giving the review in the form of zeros and ones. If the movie is bad, saying 0. The movie is good, saying 1. If the movie is good, saying 1. If the movie is bad, saying zeros and ones, right? Therefore, they're saying in the form of zeros and ones. Can you write an SQL query to count the number of zeros and ones? To count the how many goods and how many not goods. Can you write an SQL query to count the number of ones and zeros? Aggregations, grouping and aggregations, right? Single grouping and single aggregation. Try to say, select review wise, count I want. From which table? Reviews, group by review. Select review wise count from reviews, group by review. Reviewers count from reviews group by review. Output 1 and 0. Reviews means 1 and 0. How many ones? Say that 90 you got. This 10 you got. 90 people saying the movie good, 10 people saying the movie is bad. So you can write this, you can handle this kind of data. But generally reviews won't be given in the form of zeros and ones, right? Reviews won't be given in the forms of, yes. They give in their own text format. Movie is, for example, first person saying movie is good. Second person saying, okay, movie is not good. In the same way, in this, they're giving in their own text format. Can you write an SQL query now to count the number of goods and not goods? Can you write it? This kind of data you cannot handle, right? But still, if you're using this keyword count, okay, good you can count, right? But still it gives wrong computation because not good has got good in it. So it gives wrong computation, right? Yes. Review as count from reviews group by review. Yes. So these are the major drawbacks with this databases. No parallel processing, limited storage, volume increases, speed decreases, complexity increases, speed decreases, and databases can handle only structured data. They cannot handle unstructured or semi-structured, right? Yes. Now, advantages of Hadoop. Advantages of Hadoop. I'll come back to Spark later. 1 second. I'll have separate advantages of Hadoop. First thing is unlimited data storage. Unlimited data storage is possible. Unlimited data storage. Secondly, very high speed processing. Very high speed processing. Unlimited data storage, very high speed processing. Because of this parallel processing, can handle all varieties of data. Can handle all varieties of data. Is an open source. This is an open source, no licensing rate. No licensing for this cost cutting. So right. And commodity hardware. Commodity hardware means it doesn't mean that you need to have very highly configured systems, but it can have in Hadoop can be installed in any hardware. It can run on any hardware, right? So mainly unlimited data storage is possible. Very high speed processing, can handle all varieties of data. Open source, no licensing, right? Yes. Advantage limited data storage is possible. Very high speed process because of processing can handle all this structured, unstructured, semi-structured, open source, no licensing. Most of the products of this Hadoop are from Apache. You can take it from Apache Mirror's website. Commodity hardware, right? So very high speed processing. One example, right? So Yahoo has conducted a test. Right, to check the speed of different databases. Has taken a table of 100 TB. Has taken a table of 100 TB consisting of 20 columns. So the task is sorting based on not single column, sorting based on 16 columns. Sorting based on 16 columns. Sorting based on 16 columns. Yes. So now what is the time taken? Time taken for different databases. Time taken read by different databases. First, Oracle. Oracle has taken nearly 3.5 days to process this. MySQL. MySQL has taken nearly 6 days. Teradata, a specialized database used for data warehouse, has taken 4.5 hours. Right. Netija, another specialized database used for data warehouse, has just taken 3 hours, right? Finally, Hadoop has just taken 3.4 minutes. Has just taken 3.4 minutes of time, right? The latest version of Hadoop has just taken 1.2 minutes. So this is what the speed of Hadoop as compared with other things. So very high speed processing, these have taken minutes of time, but those have taken days and hours of time, right? So Hadoop is proven in the markets processing point of view, even storage point of view, right? Uh, Storage point of view also, I'll provide some examples, right, in the tomorrow session, how Hadoop is proved in the market, storage point of view, processing point of view with a very high rate of speed. Yes. Now, if I talk about this Spark, what is Apache Spark? Why PySpark? Why PySpark? Need for PySpark. PySpark features. Real life usage of PySpark. PySpark job market. PySpark job market. Yes, what is Apache Spark? What is the need for PySpark? All right. PySpark features, real life usage of PySpark, and its job market, right? Yes. Okay. What is Apache Spark? What is Apache Spark, right? It is an open source distributed cluster computing framework, right? Introduced by Apache Software Foundation. It is a general engine, I can say. It is a general engine for data analysis, big data analysis, for processing, and for computation, right? Yes. See, we say why PySpark today? Why it is the Python API. PySpark is the Python API to use Spark. Spark is an open source. I said it's a cluster computing used for big data solution. You can say PySpark is the lightning fast technology that is being designed for fast computation. It's a very demanding tool among the data engineers to work with bigger data sets. PySpark used for running distributed SQL. PySpark used for running distributed SQL. Creating data pipelines. Ingesting data into databases. Into a database. Running ML algorithms. Running ML algorithms. Working with the graphs. Working with the graphs or data streams. Running distributed SQL, creating data pipelines, ingesting data into a database, running ML algorithms, working with the graphs or data streams. Need for PySpark. A large amount of data is generated offline and online. This data contains hidden patterns, unknown corrections, market trends, customer preferences, other useful business information necessary to extract valuable information from the raw data. Right. So we require some efficient tools for performing these different types of operations on this huge data. So you may say that you have got already tools for performing these kind of operations on this huge data, but the tools are not that so much of appealing, right? It is so we require some flexible tools to crack this big data and gaining benefit from it. So PySpark, right, is a lightning fast technology. It is such a kind of technology, right? Which we can get many insights from this data. So combining Python and Spark will be the very efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark. Very high speed processing, I said. Very high speed processing. Okay. And if you see, I'll be discussing the features, main features. It takes time, but what are the real life use cases of this PySpark? Real life usage. In the commercial sector, it is used. The commercial sector, like for the banks and other financial systems, using Apache Spark today to retrieve the social customers, this customer social media profile, and also analyzing it to gain the insights which helps in taking the right decisions, and also in credit risk assessments, and also in fraud detections, with widely used in machine learning tasks. Spark has got a special library like Spark MLlib library, and also in the healthcare also it is used a lot. Healthcare also, right? Yes. To analyze the patient's records along with the previous medical reports to identify which patient is probably to face the health issues even after being discharged from the clinic. And if we talk like entertainment industry, right? Yes. See, today, if we talk about entertainment industry, it is moving towards this online streaming. The OTT platform like Netflix, it is using Apache Spark for the time processing for the personalized online movies or web series. Can process nearly 450 billion events per day that are streamed over server-side application. Trade and e-commerce. Trade and e-commerce, right? So e-commerce websites like Flipkart, Amazon, all these are using Apache Spark for this advertising, right? Even other websites like Alibaba, right, providing offers an enhanced customer experience, optimizing the overall performance, even in the tourism industry. Even in the tourism industry, right? Yes. It's PySpark used to provide advices to millions of travelers by comparing hundreds of tourism websites. So in this way, right, usage of Spark in different. So as part of this course, big data group plus Spark with Python, we select PySpark. So yes, knowledge of Linux. Python, right? Within this Python, you'll be getting this both the core and advanced Python. Nearly 50 sessions will be there on this. So for this Python, you are supposed to attend any of my Python batch. I do handle this Python course. Python, if you want to go with this, there is a Python batch, 8 a.m. in the morning. You can attend this 8 a.m. or 9 p.m. Evening, if you want to, you can go with 9 p.m. Morning means 8 a.m. But the timing of this will be at 7 a.m. Initially, it will be for 1 week, it will be at 8 a.m. We shifted to 8 a.m. But this 9 p.m. it will be at 8 p.m. Right? Yes. But this big data, Hadoop, PySpark, and Linux in this, you will have sessions on these weekends. So the timings of this will be like 5 p.m. to 7 p.m. Right. So tomorrow also people can attend the session at same time at 4:30 to see more discussion on this. Before that, you can see that course content of it. So it goes for nearly 12 weekends, right? 12 weekends, around 3 months it takes. So and observe this course content for this. Starting with big data. What is big data? Resources, challenges, arrays of Hadoop. HDFS Hadoop distributed system. Norms, HDFS. Configuring block size, name node, node, HDFS architecture, metadata management, storage and processing, replications, fault tolerance, map reduce, phases of map reduce, right? Yes, scoop, another important component for importing and exporting. Importing from database to Hadoop, exporting from Hadoop to database. During this import operation, many other things we can perform, like filtering, merging, grouping, aggregations, right? Yarn and how to write defining scoops and yarn, another resource negotiator, speculative execution, speculative jobs, speculative tasks, yarn architecture, yarn components, NoSQL databases, and NoSQL, different type of NoSQL, and one NoSQL database like HBase will be discussed, and Apache Hive in this Hive architecture. Actually, a lot of jobs, if you knowledge on this component, only this component, you can check Hive jobs, just check Hive jobs. Lot of jobs for Hive. Just check this. 30,537 Hive job vacancies in February. We have to put on this Hive. So we'll be discussing in what is Hive, Hive or Hive query language, SQL and SQL, Hive local files to Hive tables, loading data from this HDFS to Hive tables, internal tables, external tables, XML data, JSON data, URL and weblog data. Yes, inserting into HDFS, Hive UDF, Hive UDF partition tables, not partitioned, multi-column partitioning, dynamic partitioning, performance tuning mechanism, bucketing in Hive, indexing in Hive, Hive examples, Hive and HBase integrations, right? And so you'll be given knowledge of this streaming data and components. Like streaming data means data which keeps on generating, data which keeps on incrementing. Such data we call that streaming data. Capture using streaming technology like Kafka, PySpark. In brief of this part, PySpark real life use case, PySpark session, PySpark context, repartition, broadcast, PySpark quantity computation, RTDs actions, RTD competition, RTD persistence, memory only, and CR only, disk only, by support computing, different RTDs, increasing the number of partitions, groupings, and aggregations, single grouping, single aggregations, multi-grouping, multiple aggregations, process of key reduced by key, various actions and transformations, counted by key, counted by value, the function, co-group, PySpark SQL data frame, is creating a data frame, and moving data frame pandas, show structure, row class, column class, select, collect, with column renamed, variant filter, draw, duplicate, sort, group by UDF, flat map for each simple and PySpark SQL functions, aggregate functions, window functions, data and stack functions, JSON functions, PySpark built-in functions when expr, lit, split, concat, substring, translate, overlay, different months between. So different functions of this and external sources. Spark and Hive integration, Spark and MySQL integration, working with CSV, transactions and actions on narrow and wide transformations, addition of new columns, drop of columns, handling nulls, writing data back to external sources, setting of tables, data frames, and local mode, cluster mode, PySpark applications, right? Stays and tasks, drivers and executor, building Spark applications, deploying Spark applications to cluster and performance tuning, integration with Kafka, PySpark streaming components, PySpark. So Python, if it doesn't have knowledge on this Python, what is Python, why Python, features, advantages, history, installation, floods, Python options, log, editors, IDs, data, constants, variables, escape sequences, different operators, different IDs, flow statements, looping statements, strings, collections, Python lists, tuples, sets, dictionaries, functions, modules, packages in Python. There's an exception, file handling, complicated program analysis, regular expressions, database connectivity, Python data and time, like advanced selectors, generators, closers, decorators, work with Excel, matrix, introduction to data science, module, now by module, matplotlib module. This is what we'll discussed. Python in brief, I said nearly 50 sessions will be there for Python. And for this Hadoop, by Spark and Linux, 12 weekends it goes, right? So 15,000 for example, data Python, Linux, Python. So tomorrow you can attend the session same timing, 4:30 p.m. The same link to see more on this, right? Fine. So it's introductory session, like what is big data, Hadoop, what is why Spark, advantages, features, right? That's briefing you about, right? So tomorrow we'll continue more discussion, various topics. And I'm stopping for now, right? We'll continue tomorrow. Thank you all for your, thank you.
Thank you so much for valuable. It's a very brief introduction for you. Yeah, your screen is visible.
Yeah, fine. So in the yesterday we had a demo session, right? Introductory session. So what is big data? Why Hadoop and Spark? Drawback of this current databases, advantage Hadoop and Spark, Hadoop scope and job market of Hadoop and PySpark. So just I'll take 2 minutes to discuss right now. So today huge data is getting generated. Every application is generating huge data, right? Google, Twitter, Google, YouTube, email. So when currently we have got databases, but databases can handle up to some extent, but unlimited data storage is not possible, right? Drawbacks with the current databases. Drawbacks with the current databases. Before I go with this drawback the current database, right? So as data is increasing enormously, we have got a framework. We have a framework called Hadoop is meant for two things. Hadoop is meant for two things. First is storage and for processing. It is meant for storage and is meant for processing. For storage, it doesn't use any database. Using kind of file system called Hadoop distributed file system HDFS. For processing, it using an execution model called as MapReduce, and currently we are going Spark. storage area for processing map reduce on Spark. And for processing MapReduce or Spark. Okay. Hadoop is meant for batch applications. Hadoop is meant for batch processing or for batch applications. Hadoop is not for online applications. Hadoop is not for online applications. Hadoop is for batch applications. There are two types of applications. There are two types of applications. There are two types of applications. First one, online applications. Online applications. Second is what? Batch applications. Online applications. Online applications, right? Online applications. User interactive applications. User interactive applications. Here user gives the input. Here user gives the input. Example, booking a movie ticket. Making a online transaction. Batch application means here user non-interactive applications. See, here user is nowhere required. User non-interactive applications. User non-interactive applications. Here user is nowhere required. Here user is nowhere required. User non-interactive application. Yes, user is nowhere required. Example of this batch applications, right? Example of this batch applications. Railway ticketing PNR states. Currently, your status is 200 waiting status. After 1 hour, it is 50. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. It was the waiting state. Automatically, it got confirmed. Your user is no way involved. User is no way required here. Is everything happening in the automated fashion? Okay. For example, credit card statements for millions of credit card statement for millions of customers. Statement millions of customers. Statement generation for millions of customers. Phone bill statement generations for millions of customers. Right? So batch applications where involve huge millions and trillions of records. For a single transaction, for a single online transaction, Hadoop is not required. Millions of records require Hadoop. Now check this. Drawbacks with the current databases. Drawbacks with the current databases. Limited storage. Drawbacks with the current databases. Limited storage. No parallel processing. No parallel processing. As volume increasing, speed decreases. You see these queries, right? First query, second and third. First query executes faster as compared with the remaining queries, right? Query to query as volume increasing, speed decreasing, right? The first query executes faster because of 10 records, total amount of 10 records as compared with total amount of 10 lakh records, total amount of 10 crore records. Complexity increases. If complexity increases, speed decreases, right? If complexity increases, speed decreases. Total amount from sales one of 10 lakh records. Total amount from sales one of 10 lakh records. If you observe here, total amount, average amount, standard deviation of amount. Here, this first query executes faster because average amount is a two-step process. Next, standard deviation takes a lot of internal processing. And major drawback with the databases, it can handle only structured data. It cannot handle unstructured or semi-structured data. Before I go with advantages of Hadoop, you need to know something about the Hadoop architecture. Hadoop architecture. As of now, I'll just give overview about it, but we'll discuss in brief about the storage architecture and processing architecture separately. Hadoop doesn't follow client server architecture. It doesn't follow client server architecture. Hadoop doesn't follow client server architecture. Hadoop follows master slave architecture. Hadoop follows master slave. Hadoop doesn't follow client server architecture. Hadoop follows master slave architecture. It follows master slave architecture. Single master and multiple slaves. Observe in this manner. Hadoop cluster we say. Hadoop cluster. Group of nodes. Group of nodes. Group of nodes means systems connected in a network. Connected in a network. Group of nodes, systems connected in a network. There are two types of nodes. There are two types of nodes. Master node, slave node. Master node and slave node. So there are two types of nodes. Master node, slave node. Master nodes within this, in Hadoop terminology, we say it as name node. Slave node, we call it as data node. Observe, single master and multiple slaves. It follows master-slave architecture, right? Single master, multiple slaves. This is master, this is slave. S1, S2, and S3. S1, S2, and S3. Three slave nodes. We call it as data nodes. Data nodes. So in this way, multiple nodes, multiple slave nodes up to S and N number of slaves. So if you got a file f1.txt, the file size is 2 TB. The file size is 2 TB. Here each system capacity 1 TB, 1 TB, 1 TB. Each system capacity 1 TB, 1 TB, right? This 2 TB file cannot fit into any of this slave, right? It cannot fit into any of this slave. It has to be splitted into smaller parts. It has to split into smaller parts. Each one has to be stored across multiple systems. Each one has to be stored across multiple systems. Okay. Single master and multiple slaves. TBs. Okay. So the data is split into smaller parts. Each one is distributed across multiple systems. Here, two advantages we see: distributed storage and parallel processing. Distributed storage and parallel processing. Distributed storage and parallel processing. So here, this is the master node, right? Assign task to S1 slave, T2 task S2, T3 task S3. Three tasks are systems. Three tasks are executed parallel systems: S1, S2, S3. Master node responsibilities. Master responsibilities. Master node responsibilities. First one, assigning task to slaves. Load balancing. The task should be equally assigned to the slaves. The load balancing. Task assignment. Load balancing. Task assignment. Load balancing. Fault tolerance. Fault tolerance means if multiple tasks are assigned to multiple slaves, then these multiple tasks are executed parallelly by multiple slave systems. Suddenly, if any system goes down, then the task will be assigned to the other slaves. And I have to monitoring each and every slave node. Monitoring, right? Master node responsibilities, task assignment, load balancing, fault tolerance, and health monitoring. Slave node responsibilities. Slave node responsibilities. Slave node responsibilities. Storing the data and processing the data. First one is data, second processing the data. Yes. So this is how to follow the master and slave architecture. The storage of data, we are not going to do anything, right? Automatically, Okay. The file gets loaded across multiple systems, stores across multiple systems, and processed by multiple systems parallelly. So we need to give some logic, business logic. That logic will be applied on each and every partition data. Data is about this storage and processing architecture. Advantage of Hadoop: unlimited data storage. Observe, unlimited storage of horizontally unlimited scalability because of horizontally unlimited scalability. Unlimited scalability. Unlimited scalability. Horizontally unlimited number of slaves can be added. Just like this. What do you mean by horizontally unlimited scalability? If you are running a business with very less number of systems, now you have got only 10 systems. Assume you have got 10 systems like this. Your business has increased, your customers have increased, your branches have increased. Means customers increased by 100 times, data increased by 1,000. You cannot go with the same number of systems. Horizontally, you keep on increasing. Horizontally unlimited slaves can be added, right? That horizontally unlimited scale. You can keep on adding slaves terms. We say it as commissioning and decommissioning, adding and removing systems. Very high speed processing because of parallel processing. Very high speed processing because of parallel processing. I'll give an example, right? For very high speed because of this parallel processing, right? Yes. Very high speed processing because of parallel processing. See, if I talk about non-parallel and parallel, right? Yes. One person preparing one item. Taking 1 minute. The same one person preparing 10 items. How many minutes? 10 minutes. The same person preparing 100 items. Taking 100 minutes. The same thing if you apply with the parallel, right? The same one item 1 minute only. 10 items 1 minute. 100 items 1 minute only. So anything 1 minute only, because there are 10 persons preparing 10 items taking 1 minute, 100 persons preparing 100 items taking 1 minute. That's what parallel processing. There we say some slaves, right? That is because of process, very high speed you are going to handle all it is of structured, semi-structured, and can handle all it is of data. Structured. Open source, no licensing required. Commodity hardware, right? Can run on any hardware configuration. Doesn't need highly configured systems. And here I got query why data storage cannot support unlimited storage. A question, right? What databases question is? Databases like Oracle not support unlimited storage. We talk in real time. Databases like it can go with multiple layers. Can go with multiple slaves. Means there is a limit on the limit applied there. For example, databases, and max number of slaves. Oracle max limit on the number of slaves. Systems actually can go with 256 once 256 nodes when systems are CPUs. Once the data is full, it cannot support data further. MySQL max 54 only. 54, but MySQL Express you can go with the 256. SQL Server, SQL Server, SQL Server is going with maximum 56. DB2, it goes with 56 nodes. Like 256, MySQL Express, SQL Server, DB2. or like it is not so much SQL server with us. Now this database is data storage, right? Once it's free, they cannot support data further. Once this is not successful, the system promise will be degraded. Just like a mobile phone. For example, in a mobile phone, 128 signals to for 1 GB is even your phone even starts. The same points degrades same also. All the 256 performance of the system. You have got such database like that. It's going with the maximum 512. 5, even Medija going with no limit. There is no limit on the number of slaves. On the number of slaves. But there is a number of slaves that Hadoop. There is no limit on slaves that you can have. Unlimited number of slaves, right? Or unlimited scalability, right? Yes, but there is no limit on the number of slaves. Unlimited number of slaves. Yahoo, when first time implemented Hadoop. When Yahoo when first time implemented Hadoop, when thousands nodes passing its data. Yahoo when first time implemented Hadoop, when 4,000 nodes stored its data. Currently, Yahoo going with 12,000 nodes for storing data. Facebook, when first time implemented Hadoop, 8,000 nodes, 8,000 nodes for storing its data. Currently, Facebook going with currently Facebook going with 52,000 slaves on nodes for storing its data. Yes, Facebook when first time implemented went with 4,000, 8,000 nodes for storing data. Currently, Facebook going with 52,000 nodes for storing its data. Right. This is what Hadoop is proven in the market storage point of view and also processing point of view. Yesterday I was discussing about this processing point of view. Yes. Check this. This processing point of view. Yahoo is taking a block and it consists of 1,024 columns, sorting based on 16 columns. So Oracle has taken nearly 3.5 days to process this. MySQL has taken 6 days. It has taken 4.5 hours. It has taken 3 hours. Out of 3.4 minutes. And data version of our class just taken 1 to 2 minutes. Taken 1. Okay, now in terms of Spark, right? Hadoop speed is already 5 minutes as compared to database. Like or the of time, how has taken minutes. Hard to speak about the Spark is 100 times than Hadoop. Already Hadoop has got a great food. Spark is 100 times faster than Hadoop. But in the current industry, both Hadoop and both commonly used. There are some two components used and Spark both commonly used for storing and processing data. So what are the components? Two components mostly used in the market I'll be discussing, right? Along with Spark. What is a Spark, right? Yesterday I was reading about this, where we can take like distributed cluster computing, right? For data analysis, data processing, and computation. So Spark is the uses Spark. So like fast technology that is a fast computation. One of the demanding among data engineers with the big data sets is for running distributed, for creating data pipelines, for just databases, running algorithms, with our data streams. Right. So need for PySpark is like getting generated every